In the lessons leading up to this one, you've learned that matter is made up of three basic building blocks. The most basic is the atom, and then the molecule, and then the crystal. Then, in the previous lesson, you learned that depending on how those building blocks arrange themselves, matter can either be considered pure matter or mixed matter. In these lessons, what we've been doing is starting at the most general topic, matter, and then breaking matter apart into categories that help us to better make sense of exactly what matter is, whether matter is pure or mixed. In this lesson, we're going to continue developing that same theme. We're going to focus in on pure matter and learn that pure matter is actually itself made up of two categories, different types of pure matter. And those two types are elements and compounds. And just so you know, we're not done yet. There is one more level of specificity here, one more level of categories that we're going to be looking into as we break apart elements into specific types of elements and compounds into specific types of compounds. As you're working to keep all of this straight, it is imperative that you make a good, cohesive concept map that has all of these levels of specific categories mapped out, and use that to help your brain keep track of all of these different categories that we're learning about in these lessons. Let's get started learning about elements and compounds, and I don't think there's a better way to do this for understanding than to look at a bunch of different actual substances that are pure and mixed matter and start by arranging those real-world substances into their categories as to whether they are pure or mixed. So let's start with these substances that I have on the screen. We're going to start at the lower right-hand side as we take a look at iodine gas. Iodine tends to form this toxic purple gas substance that's made up of two atoms of iodine bonded together into different molecules. Would that be a pure substance or a mixed substance according to our criteria? Well, remember, we said that there are three building blocks of matter: atoms, molecules, and crystals. And if a type of matter is made up of just one of those building blocks, then it has to be a pure substance. In this case, iodine is made up of only iodine molecules, and all of the molecules are exactly the same. They all consist of two iodine atoms. So iodine is clearly, in this case, a pure substance. Next to iodine, we have a noble gas substance, argon. Argon can be found in high-intensity lights, like some flashlight bulbs. Argon is made up of single argon atoms as a gas. Because there's just one type of atom and all of those atoms are exactly the same, we have just one type of building block that makes argon a pure substance. Moving along, the next substance we have is iodized salt. Iodized salt has a couple of different components in it. It's made up of sodium chloride, which is the table salt part of it, but there's also potassium iodide in it, another type of salt that, just like sodium chloride, it tastes like salt, but it also provides people with iodine, a necessary element in their diet. Because there are two different kinds of building block in this substance. There's the sodium chloride crystal and the potassium iodide crystal. This is mixed matter. It's more than one type of building block, and they're not bonded together as one repeating unit. They're separate units. Next to iodized salt, I have another substance. This is a bismuth crystal. Bismuth tends to make these really interesting square-shaped crystal patterns. Notice that this crystal is uniform throughout. It's made up of the exact same pattern of atoms throughout the entire crystal, and that qualifies it as pure matter. Next up, let's go over to the right again. I have some straws that are made out of the cheapest kind of plastic, low-density polyethylene. Those two large molecules that you see there are made up of carbon and hydrogen, and they actually repeat beyond the picture as these long chains of carbon and hydrogen. Because those molecules are exactly the same all the way through, and they repeat carbon and hydrogen units, that's going to end up being a pure substance. Next to the straws, I have nail polish remover, which is made up of water molecules mixed together with acetone molecules. And it works great for dissolving nail polish off of fingernails. Acetone nail polish remover is a mixed substance because I have two different kinds of molecules. I have the acetone molecules and the water molecules. That's two different types of building blocks. That's going to go over in the mixed matter column. The next substance I have is ether. Ether is used to dissolve a lot of substances that water or alcohol will not dissolve. Ether fits as a pure substance because every ether molecule is exactly the same as every other ether molecule. Sure, they may be rotated around, but they still have the same number of individual atoms. 1 oxygen, 4 carbons, and 10 hydrogens. And then finally, potassium sulfate is a substance that is oftentimes used as a fertilizer in soils that are missing potassium. The number one crop that is fertilized in the United States using potassium sulfate is tobacco. But this potassium sulfate fertilizer would be a pure substance because the crystal is the exact same all the way through. Even though the crystal is made up of different kinds of atoms, they're bonded the same way. So I can separate matter into these two categories based on their building blocks. All of the pure substances are made up of the same building blocks throughout, whereas my mixed substances have different building blocks. But let's focus in right now on just the pure substances. And you should notice that there are actually two different types of pure substances, and I've separated them with the line. Do you notice what's different between the pure substances on the bottom and the pure substances on the top? They're all pure because they're all made up of a single building block, but the ones on the bottom have all the same type of atom. And if a substance is ever made up of just one type of atom, we call that pure substance an element. Elements are made up of one type of atom regardless of how those atoms are bonded together. So if those atoms are bonded together as molecules like iodine, because it's just iodine atoms, it's still an element. If they're individual like argon, it's obviously an element because it's made up of individual argon atoms and there's no other type of atom there. And even if they're bonded as a crystal, like that bismuth crystal, it is still an element because it's just one type of atom. If you have a pure substance that's made up of one type of building block, but those building blocks have different types of atoms in them, we call that a compound. So the potassium sulfate fertilizer crystal, because it's one repeating crystal, it's still one building block of matter, but there's different atoms. Therefore, it's a compound. Ether is made up of carbon, oxygen, and hydrogen atoms. They're bonded together the same way, so it makes it a pure substance, but it's a compound and not an element because there's multiple types of atoms. And then the same is true of low-density polyethylene because it's made up of carbon and hydrogen atoms, two different types of atoms. Even though it's the same substance all the way throughout, it's still a compound and not an element because there's more than one type of atom. These are all pure substances, but elements have one type of atom, compounds have multiple types of atoms.